Lô test mic cái mọi người nghe mình nhỉ?
Alo. Yo, I literally have to push the button to talk. Why is that?
Okay, hello.
Okay, shall we start?
I think we should start.
Okay. Okay. Hey everyone, welcome back to another OpenGuild community call, brought to you live by OpenGuild and Polkadot Insider. As an open community fueled by Web3 innovators, OpenGuild is excited to connect with all of you as we continue to advance the Polkadot ecosystem within the Southeast Asia. Join us on Discord and X to become part of our thriving community. Today, we will take a deep dive into Vara Network to learn about infrastructure for secure smart contract developments. We will cover key topics like its smart contract architecture, the actor model, persistent memory, and the benefits of a non-fork architecture, alongside with a demo at the end. So without further ado, let's welcome back Tin, our dev relation lead. Hi Tin, how are you?
Hi, PR. I'm not very good here today because I have a cold. But yeah, gonna try my
Ah,
best.
that's okay. I can still hear you really well. So, just a little brief before we actually get into the topic. So, tell me a little bit about why we're choosing this topic for today.
Yeah. So in fact, like Vara Network doesn't have much connection with Polkadot because like Polkadot
Sure.
is not like Vara Network is not a parachange, so it's not using the underlying Polkadot protocol. But in
Mm-hmm.
fact, like Vara Network is built on top of Substrate. And substrates, act as a very important role in the Vara network and also the gear technology, the core foundations of the Vara network. So the main purpose of this call today is to guide you guys like to how like substrate can be powerful enough to not be just a part of Polkadot, but it's also a part of other blockchain network as well.
Yeah, I think it's great for you to actually highlight that because like Substrate, it's a very powerful tool, a very powerful language for us to use. So yeah, let's get right into your session today. So I hope you're okay. Tin, I'll leave it to you.
Let me share my screen. All right, can you guys see my screen?
Yep, we can.
Okay. Can you guys see my slide?
Uh, I haven't seen yet, but I can see the screen already.
Mm. Can you guys see my slide?
Okay, it's on now.
Okay, okay. Yeah, let's begin. So about like today community call, we're gonna talk about Vara Network, and it's also an infrastructure for a secure smart contract development. And I think this is a very interesting topic. If you already know about like highly synchronized network like Solana that provide a parallel processing infrastructure for smart contract development. So Vara is also like have something similar to that, and we're gonna try to discover more in this community call. A little bit about myself. So my name is Tin Chum, and I'm a developer relation lead of OpenGuild. On the other hand, I'm also a Polkadot Blockchain Academy Wave 5 graduate and Polkadot SDK contributor. Meanwhile, I'm working professionally as a software engineer for one protocol in Polkadot. About OpenGuild for anyone who haven't joined any community call before yet. So OpenGuild is a Web3 hub for Polkadot enthusiasts in Southeast Asia region. We mainly focus on delivering the quality workshop and also resources for all the builders in the region for them to learn more about Polkadot technology and also the ecosystem of Polkadot as well. So here's like some activities of OpenGuild Lab. We build a lot of tutorials about Substrate, Rust, and also like hackathons to guide like the learners and also the builder to apply the Polkadot technology into into their work professionally. And we also like capture some our key moments in the past event in the C country as well. For example, like the Sub-Zero event, the developer conference in Thailand, and the Malaysia Durian Party in Malaysia, and we also have some other key moments like offline workshop in Vietnam and some community call. Let's talk a little bit about open contribution bounty. So if you're not familiar with this yet, we still have the open contribution bounty running, and the total price pool of the open contribution bounty is up to like $20,000. What is the open contribution bounty? So it is a rewarding initiative offering a total prize pool of $20,000 to participants who contribute to the development and documentation of various substrate-based blockchain projects. The open contribution bounty is currently five track. The first track gonna be substrate course. If you interested in software development, so you can build a substrate project and then document it out. So then let's share it to other people. Then submit your work to the communities to claim the reward. We also like have a structured ecosystem open source documentation. So if you can find like any like open issues on maybe like Polkadot SDK repository or many or any like other repositories or per change in the ecosystem, that related to documentation. So contribute to it, submit to the community, and then claim the reward. Technical blog, I think like the technical blog is the most popular track. Most people like write the blogs, share to the social, um, receive the approval from the team, and also like claim the reward. We also have other two track, which is a workshop technical activities. So you already familiar with like OpenHack Chopstick or OpenHack DDoT, OpenHack Substrate. So those OpenHack series tutorials um, are in the track 4. So if you want to build, if you build something like that, feel free to submit to this track to claim the reward as well. The track file or other open source contribution. So if you join like the past workshop or OpenGuild recently, you might know like there's some missions listed on our community platform at app.guild.wtf, and then you contribute to those missions. So those mission actually is in the track 5 open source contribution track. Okay, so yeah, they shouldn't have this slide here. Okay. All right, so let's learn about Vara and also Gear technology. So what is Vara? The Vara network is a sovereign layer 1 decentralized network. So it's built on top of Gear protocol. We're gonna dive deep into Gear protocol later after this slide. And so like why we want to learn about that. So Vara is a layer 1 blockchain supporting developers to run like WebAssembly compiled smart contract, implementing like developer friendly Rust libraries, and developers and user enjoy low transaction costs. Yeah, we also have a slide here. So like some key attribute of Vara can be mentioned as low transaction costs, gas fee rebates, stacking, governance, and parallel processing. So when you read the definition of Vara here, you might find like, why? So it is quite similar to what we already know about Substrate and about like other blockchain built on top of Substrate, right? WebAssembly, what else? Like layer 1 kind of things. So all these things are built on top of Substrate framework, and it's also like customized. Um, yeah, based on that as well. So here's a Vara. So Vara is equal to the first layer of Vara is the WebAssembly smart contract. The second layer, Gear protocol, and the underlying layer is the Substrate. So you can see the Substrate is still the foundation of our network, and Gear protocol is the layer that built on top of it, and tune the Substrate framework to be like compatible with the designs and also the decisions from the Vara engineering team. And we also have WebAssembly smart contract. This already familiar with like most of the builder in Polkadot already, like to in development. When we talk about this slide, so Vara is not a pair change, but it's a solo change. So Vara network is built using the gear technology, but it's not registered itself as a pair change. So it doesn't use the key features of Polkadot like native state security or what else like deployment, easy deployment to the Polkadot protocol, and it cannot use feature of Polkadot protocol like POV reclaim or async backing or elastic scaling as well. So if you visit the Gear technology GitHub, it's stay at like Gear Tech Organization slash Gear. So you can find like here's the code base of Gear technology. And when you visit the runtime, you can see Vara there. So I can say you can imagine like Gear is like Polkadot SDK, and the runtime Vara is like Rococo or like Polkadot or like Kusama. So it's just a runtime built using the technology of Polkadot SDK, but in this case the gear technology, so you guys like can explore this thing by on your own. Okay, so we're gonna go from the bottom up. The third layer of Vara network is Substrate. So what is Substrate? So Substrate is a base blockchain framework used to power the Polkadot SDK. Is a full toolkit to create sovereign blockchains, including but not limited to those who connect to Polkadot as a parachain. And I think like Vera proved this statement already, like including but not limited to those who connect to Polkadot as parachain, because like Vera stay as a solo change. So like some key component of Substrate, we can mention the first one gonna be like the lib B2B, which is a networking layer. Um, WebAssembly, platform agnostic language, and consensus layer and database layer as well. So in Substrate node, when you compile, it's also like become a WebAssembly. Um, but like this WebAssembly is different from the WebAssembly you might know on about on the smart contract level, because this one is just for the node and the runtime. Some key attribute of Substrate we can mention as Substrate is ready to hack. You just claw like install the Substrate node, and then you have like a full toolkit that can be ready to act as a one blockchain node. And the Substrate client include some key components like the peer-to-peer networking, the RPC that provide like or the external user can send any queries or can like submit any transaction to the Substrate node. The WebAssembly runtime, which is the core of the whole Substrate client, the storage and consensus and telemetry service as well. The second key component in modular design you can see here, highly customized forkless upgrade. The forkless upgrade is also like the very key attribute that most people choose Substrate to build their blockchain, because like not every blockchain has this. So whenever you want to do any upgrade on blockchain like Ethereum, which is like a very long legacy system. So you have to do like hard fork or soft fork to do an upgrade, and that is not very nice in terms of user experience, because like the experience gonna be like interrupted if the engineering team is not doing well. So building with Substrate, so Substrate has three key components: the node, runtime, frame palette. The node is responsible for doing all kind of stuff like consensus, P2P networking, block productions, kind of things. The runtime will be the central hub of all the palette, which um, navigate all the runtime logic, or I can say like all the computing logic of your node. Yeah. So the frame palette is like a very small module. It can be seen as like the minimal, not like the minimal, but like the smallest computing unit, the smallest design unit of the whole Substrate node. That is act as a, like programming a logic for your Substrate node. And frame is optional for Substrate-based change, because you doesn't need frame for your node to work. But like with frame, let's make things much better. So what is a frame? Frame development environment provides module called palette and support library use, modify, and extend to build the runtime logic to suit the needs of your blockchain. So if you search the frame marketplace or frame ecosystem project, you can discover like there's a bunches of palette on the marketplace right now. For example, you can like find the open runtime here like the ORML, the open runtime something I forgot, but it's also like from the community that build a palette for the community. And some detail architecture of Substrate. So we have the Substrate client. We already talked about it, and you have Frame. So Frame gonna stay in the WebAssembly runtime. And you can find like there's some common Substrate palette like over, Ranper, pseudo, asset, Chessery, all these kind of things like specify some logic for the runtime and for your blockchain. So when you go to the Gear Technology GitHub, you and can also like find the node, the palette, and the runtime here as well. Um, Gear Tech, they reuse some of the palette of the frame libraries like stacking governance, but they also like come up with like some set of their special palette to support their own use case as well. And what is their own use case? We're gonna learn about Gear Tech in as the second layer of the Vara Network. So Gear Tech or Gear Protocol, which provide a comprehensive toolkit for quick DApp creations, and it have like three key components: the actor models, persistent memory, and WebAssembly. So what is actor model? Actor model is a very well-known concept in computer science. It's not just a special concept in blockchain, but like in computer science in general. So actor model is a well-known approach used in high-frequency parallel computation. So any system that wants to provide the ability to do parallel computing that they're gonna like consider come up with like these actor models. So you can also like find a very common library from Rust, not like library but a framework from Rust called Actix, which is an actor framework allow you to do asynchronous programming. It is quite similar to like Tokyo if you are a retractions or if you know already like do web programming in Rust, you might know about the Tokyo. So like these kind of libraries follow the actor model that allow you to do like asynchronous programming easily, and yeah, so you can learn about it. So why you want to do the actor model? The principle of the actor model approach is that programs never share any state and just exchange messages between each other. In that way, like each actor that has their own private state, and the actor is the atomic computation unit. An actor can also become a program or a user that send message to a program. So the actor model is help to make the system more secure, because like now like the state is not conflicted together. Instead of like in the blockchain, for example, if you do like pallet contract, um, like the pallet contract, let's share the same state. All the smart contract like have to commit with the same state to the pallet contract, to the global ledger of the blockchain network. But with Vara Network, this doesn't happening. And here, like you can see, we have like our system, and we have like some actors in the system. Each actor has their own mailbox, which is like a message queue in computer science. And each actor gonna like send a message to the mailbox of the another actor, and then waiting for them to come back with any message in the time being. And one thing must be noted and noticed as well, which is that like the actors do not share memory. That means like each actor has their own isolated environment and doesn't conflict with other actor in the same system. And here I also like have the flow that I hope you guys to learn more about the actor models. So understanding the actor models, yes, you can see here is our application, the controller, which is the our app. We have like two set of actors. We are payment actors and the shipping actor. And this payment actor and the shipping actor doesn't conflict with each other, doesn't rely on each other, and they has the old state as well. So if you like call to the method like handle checkout, and it just basically like do asynchronously call to method payment actor ask and shipping actor ask, that sending the information, sending the message to the message queue of these two actors. And remember, like these two message queue are isolated, so that the payment actor gonna receive the information about the payment info and return the response in time being back to the main actor, which is a shopping cart, because we already know in this slide that is the actor can also become a user that send message to a program. So in this case, like the third case applied to the shopping cart for a program. The second case applied to the payment actor and the shipping actor. In that way, like you can see, like we have like three separate actor, which has their own state and their own process as well. So in the Vara network, there's three key features that actors can has their role in. First is the message communication. So actor models for message communications. Program and users communicate securely to messages, ensuring efficient, reliable, and scalable interactions. Yeah, so as you can see right here, I already mentioned that like every actor has their own state, has their own message queue, and then any interaction between actors doesn't block other actor process, similar to a thread in CPU. Um, the second one would be built-in actors for enhanced program capabilities, because like actor can act as a program in the system. So in that way, like Vara Network also like provide a set of program. For example, they can provide like a set of program like payment actor and shipping actor, that the developer just have to send a message to the actor and receive something back from it. They don't have to care about how does the actor do, uh, similar to a black box. Um, if you're familiar with like Solana, you can see like in Solana we have the concept of like program, and this actor model is also like similar to what Solana have for the program. Asynchronous processing actors model is very common for asynchronous programming, and in that way, asynchronous processing is not excluded as the key features of Vara Network as well. The second key features of gear tag gear protocol is the persistent memory. So the persistent memory approach and clever memory virtualization technique ensure your data is always available and secure. This enhances ability, and as a program can read and write only within its own memory space and has no access to the memory space of other program. This persistent memory features is very helpful to deliver something asynchronous, because like now you don't have like any computer science issues like ray conditioning, uh, because like now like your program has your own memory space and it doesn't conflict with the other. So in that way, like if you mutate if you mutate the memory space of one program, it just come to mutating that memory space and doesn't conflict with the other. And some bullet points from GitHub that say persistent memory. When working with memory, there's no shared storage, as I mentioned. Each program has access only to its own memory. All program memory is stored at once. While writing a program, we work with local memory. So the system perform only two memory operations during program execution. And here's like visualization for you to understand about the process of how the program communicate with each other, and also like working with storage the underlying storage. You have like very global message queue that send the message to the program will handle the message as an actor, but they also like have their own like storage. And you can say like you have like multiple program right here that can be separated into like a separate message processing stream. This is also a concept in advanced concept in actor models in Vara Network, but like because I don't have time, so I cannot go to it. But yeah, like after all these kind of operations separated into multiple cores, similar to like CPU core that you already know in traditional computer science concept. Uh, After that, like all the state will be synced together and then added to the global message queue, similar to how the Polkadot parachange assigned to the execution core of the relay change, and then handle the state, and then send back to the relay chain to commit to the old global ledger. And we talk about the first layer of the WebAssembly smart contract. Uh, so for WebAssembly smart contract, yeah, so in Polkadot SDK, there's a palette called palette contract. And if you already work with it, you might know like if you want to provide features like in smart contract programming, you must add and also configure this palette contract to your Substrate runtime. And in that way, like the palette contract has the ability to come to like execute any like WebAssembly block. Um, and that you can see like the WebAssembly is a very common language, common bytecode language that acts as like the intermediate representation for all the high level language. So that like it can be agnostic and independent across the whole environment. So we also have some high level programming language that can be compiled to WebAssembly block and be able to execute the pipeline contract already. For example, the first one going to be ink. Um, the first one gonna be ink, second one solidity. So that's mean Palette contract has all the ability to execute the solidity smart contract yeah, from Ethereum, and ask assembly script EDSL. So but this Palette contract was gonna be replaced by a new palette called Palette Revive. It's actually still Palette contract, but it's gonna be replaced by like Palette Revive. And this palette revival, instead of like compiling and executing the WebAssembly blob, is gonna executing the the PVM, which is the Polkadot virtual machine blob. And this is gonna be like a very big upgrade for the upcoming jam. So if you guys interested, you can guys can search that on Polkadot forum and read more about it. So how does it work with the smart contract in Vara? So for any smart contract, using the GUI technology, you have the metadata that contain the information about the input output type of init, metastate, and handle. So what is init, metastate, and handle? So init function perform one-time loading tasks, so as initializing the state. Um, yeah, this is like state preparation before like you do any execution later. The state contain the variable necessary for the program logic. Yeah, after the init, you're gonna receive the state, and then you go to the meta state, which the function allow for free state reading without gosh to queries. And this like quite great because like it help you to do like reduce the cost for operations of like executing the smart contract for any like queries and this meta state functions. Handle define the main logic based on the received message and update the state, and handle reply define the logic based on the messages as a response from other contract, allow for asynchronous processing. All these like handle and handle reply is where the actual model coming in, that like you can define the main logic like sending the message to any like other program in the Vara network, which is the actor. And the handle reply is that you handle the asynchronous processing computations from the Vara network as well. And I think like from that is also like the wrap up for all the slide here today about Vara Network. And I hope like you guys like can understand like how Substrate can be powerful enough to be a part of the Gear tech, Gear protocol, and can like provide the parallel processing um, ability to the Gear protocol to the active model and also the persistent memory. Um, and yeah, thank you for listening to the community call. Yeah, if you guys have any questions related to the community call, feel free to ask. Hey, let me create a group of work, and then we're gonna wrap up our community call today. Um, one thing is like I really interested in like hearing in like receiving any feedback from the community members. In fact, like we really want to do something often, maybe in the future, instead of just like doing something like a workshop format. So like if you guys like have any ideas or like have any interesting topic that you want to bring up in the community call, feel free to leave in the chat box. So like we as a team gonna like receive the feedback and then see that if we can execute that in the future. Yeah, all your feedback is valuable. Technical content, yeah, technical content is still open, so you can still see it in the bounty. One question is, does Vara Network use contract palette? Is it possible to use Ink to develop smart contract in Vara? Yeah, in fact, like Vara Network doesn't use palette contract. It has its own because it has its own execution model. Palette contract is the execution model from Polkadot SDK. Um, and it has the like Polkadot SDK design the palette contract to have its own like memory space design. Also like how like the smart contract like can communicate with each other to the Polkadot protocol. Um, for example, like the in contract, in fact, like can do like asynchronous communication to ECM on the contract level. But if you just configure the palette contract on your own solo blockchain, you doesn't have this capability to do ECM if you not become a parachange. So in that way, like because Vara Network is a part of is Vara Network is a solo chain and it's separate from Polkadot. So in that way, like for them to provide any like capabilities for like Ghost contract executions and also like doing like parallel processing, they have to redesign the old like, memory storage and also like how the smart contract can be and access to the storage of the underlying protocol. And on the other hand, as I mentioned, because like they want to follow the Atom model to provide the asynchronous processing capabilities. So in that way, like they also like have to come up with the old palette to configure the runtime for this type of stuff. So I can say like the answer is no. They doesn't use palette contract, but use the old execution palette to handle that. Is the concept of program in Vara similar to a smart contract? Uh, that's an interesting question because I actually not deep into this topic. Um, but I can say I think like it's yes, based on what I understand. How do they do gasless transaction? Yeah, remember like I'm not very network developer relations. So but yeah, I'm reading the article right now to answer this question. So from the article of Vara, payless transaction gas fee interaction experience. Uh, yeah, so each smart contract has internal vouchers pay is similar to like subscription feature in other block like paymaster in like account transactions where the token can be set and user can be configured to use the token to perform specific operation while setting a time of period. Da-da-da. Yeah, so I can say like they have some kind of mechanism similar to paymaster in our abstraction blockchain. Silas transaction. So I also have another feature called like Silas transaction. Like you doesn't have to start to prove that like this transaction is coming from you. And you can still like dispatch the execution. Yeah, so user only need to send information after logging in to the system without signing each time. Yeah, this is like one-time sign, and then later they just use your key to sign on behalf of yourself instead of like asking you to sign multiple times. But I'm really curious like how that they can handle the security concern of this approach. And we also have the GitHub of Gear Tech right here. So if you go to Gear Tech, this my this code base is a bit messy compared to other blockchain code base, but you have like the core backend, core errors, core processor. So I think like these kind of things are like core libraries of Gear. The core processor right here is the what handle the parallel executions. Um, if you go to the palette, this where they configure the runtime, and you can see that all these kind of things that have the gear refix, and you have like gear program. And I guess this one is the API to work with program and binary code. Uh, So for Leo, like if you're interested in the smart contract and how that they can uh execute that in Gear Tech, then you can discover the code base on GitHub. And you can see that right here, like they have like they use library like SB runtime or frame system, and this library is coming from Substrate. Like it's also a concept of Substrate, not other ecosystem, not other tech. Yeah. Anyway, I'm gonna send the link here. So if you're interested, you guys can learn more about it. Another question is, you can find a Substrate repo template for debuting smart contract using it. Um, Substrate repo template. Or for the code base related to a smart contract using ink, you can consider using the Substrate contract node directly. This one is the uh, Substrate node that has the palette contract configurations. On the other hand, um, most of the time I'm gonna use the pop CUI with, yeah, let me send you the CUI. Here. There's a guy on PopCUI page. PopCUI is basically just a tool for you, a CUI tool, a toolkit for allow you to do like seamless Polkadot development. It's make things easier for yourself. So on PopCUI page, you can find a section called like create a new parachain, and you can visit that, and it show you like all the steps to create a new parachain. It's also like have the palette contract configuration as well. So feel free to use that. Otherwise, just use the one from Parity. Uh, that one is also standard. So yeah, hope that help you. All right, guys, any other questions? The more ZKB feature, what do you mean? Like ZKB feature from what? From Vara? Yeah, that thing is quite interesting because like, I'm not again I'm not an expert in Vara. So, but I also like found a few documentation about this feature, the ZKML, zero knowledge proof things. And I'm actually I'm not very interested in cryptographic things. So, but yeah, I think like in the doc they show you a very clear guide on how to use the ZKB feature. They have all the kind of things like prover, user initializer, verification outcome, how you can integrate that to your smart contract. And there's a short code for the actor. So this one is external ZKML actor, and as we mentioned, the actor is basically just a program in Vara. So feel free to visit that repo. You're gonna find, maybe let's just share the screen. Yeah, feel free to visit this, and in here I can see the contract and sort librs. And I think like this one is the code base of the smart contract on Vara. And in this code base, let me skim to it. You can file a handle initialization, and as we just mentioned this in the slide, the first process gonna be like init, and this is the init stage that like do on top state initialization. Um, and yeah, they also like have some example here that you can see how to apply that to your own use case. And they have like handle prover message. So prover is like the actor, not the actor, but the entity handle the process. If the proof of ZKB proof submitted to the network, the prover gonna like step in and then like verify if the proof is correct, then return back the result back to the sender and handle the client message. And I think they also like have event that is quite clear to read. So maybe if you're interested, you can dive deep into this. Okay. So I think that's also a wrap up for today community call.
Okay, thank you, Tin, for sharing a lot of insights today and, of course, answering all the questions. I guess this is the end of our session today, and we hope you found today's sessions as enlightening as we did. A big thank you for Tin for sharing his expertise and for the demo that showcased the potential of Vara Network. If you have any question or feedback, feel free to reach out on us on Discord or X. So we appreciated your input. We look forward to seeing you at the next call. Until then, keep innovating and connecting with our community. Have a great day, everyone.
Thank you, everyone.